Question number 11 is very similar to question number 7. It says at noon, a ship is 100 kilometers due east of another ship. A is sailing west, and B is sailing south at 10 kilometers per hour. At what time will they be nearest to each other? So we have a point B that is sailing south. We have a ship A that is sailing west. So A is out here, B is up here. Right now, B would be at point 00 and traveling south, and A would be at point 12 0. I'm sorry, it's 100 kilometers, so it would be at 100 0. Now, as they sail, A's x coordinate is going to shrink by 12 kilometers per hour. B's y coordinate is going to decrease by 10 kilometers per hour. So when they get to the point where we're measuring, let's say here and here, A is going to be located at 100 minus however far it has gone and 0. And B is going to be located at 0 and however far south it has gone, which is negative 10t. The hardest part of these problems is figuring out the coordinate of the boat. Now, once we have those coordinates, it's just optimizing the distance between them, which is just the square root of the difference in their coordinates squared. So 100 minus 12t minus 0 is just 100 minus 12t squared plus 0 minus negative 10t is just 10t squared. And we can switch the order of the subtraction because subtraction, when we square it, is going to become positive anyway. So it doesn't matter that I switched which one was 1 and 2. So now we're just going to simplify this out. Simplifying this out is going to give me 144t squared and 100t squared. So 244 t squareds. And then from the first one, 12 times 100 twice, so minus 2400t. And then plus 100 squared, which is 1 with 4 zeros, or 10,000. That is going to be my function. But even that, if you'll remember from the earlier problems, we're only going to optimize the inside. So my derivative is going to be 488t minus 2400. A much easier derivative than it looked like that might have been. Now, what we want to know is critical values. So where does that equal 0 or undefined? Well, it's 0 when 488t equals 2400. Well, that happens when t is equal to 2400 over 488, which when you reduce that is approximately 4.918. So that's my t value. So my second derivative will confirm if we have a maximum or a minimum that we wanted. So my second derivative is 488, which is greater than 0 no matter what t is, which is concave up, which makes that a minimum. We were trying to get where the two ships were closest to each other, so we wanted a minimum. Now, what it says is at what time and at what distance. So this part might be a little bit more complicated. This is how many hours after it left. So if it left at noon, it's 4 o'clock and however many minutes. So 0.918 is in hours times 60 will give me minutes. 0.918 times 60 is about 55. So what that means is it was sitting at 455 closest to the other ship. Now, to figure out the actual distance, all you have to do is plug this number, this 4.918, back into your distance formula, including the square root. And that is definitely a calculator thing, but that distance is going to turn out to be approximately 64.018 kilometers. So, how long and or how far and when? And we've answered the question.